side and the wrong thing's on the wrong side.
Cosine equals 87 divided by 105, the square root of 105.
I mean, I can't always be their little girl.
During our earliest years, thinking and language develop together. Like two embers feeding a growing flame, these mental fires slowly illuminate the outer world to the child's growing mind.
Baruch,
Baruch,
Atah,
Atah,
Adonai.
Adonai.
And the world responds, shaping the child within a cultural framework. Words and even signs link the youngster to a past, rich in tradition and meaning.
Alex,
Share,
Share,
Nel, Share, Shabbat.
Shabbat.
Around this glowing fire of language and thinking, the child's mental dance with the world begins.
Sabbath.
Shabbat.
Good job.
Hi, you want to pet the dog? Okay, go ahead. What's your name?
Jimmy.
Jimmy?
When we think of what makes us unique as a species, language immediately comes to mind. Human children typically begin understanding and using words and gestures within the first year of life. This remarkable ability has led many to wonder, what are the origins of language? In part, clues to this mystery lie in observing how children learn to communicate.
Poor baby, I said, ow!
When we're talking about communication between human beings, we're talking about active communication that the child carries out on purpose. After all, when the newborn cries, Lord knows that's communication. Try to ignore it. You can't. We're evolved to be unable to ignore that cry. So it communicates to us. But did the baby cry in order to communicate? Probably not. No, a point comes in downstream, about 8, 9 months of age, where there's no question, but the baby is using his signals, using the sounds and the gestures on purpose, trying to communicate with you, and that's one of the building blocks of language.
Now, in some sense, you can say that children don't really begin to speak until, or to talk or to understand language until they're in their second year. But in fact, most infants begin to understand language around 9 months of age. And so you can ask, well, how could a baby that had no concepts or no ideas about things, and certainly no symbols, how would they be able to begin to acquire language?
Infants first know about the world through their senses in what pioneer psychologist Jean Piaget called the sensory-motor stage of development. But is this how children learn language?
I think it probably would be an impossible task if they had to map the words that they are hearing onto the sensory-motor accomplishments that they have acquired to date. You really need, well, I call it a 3-tier architecture in infancy, that you can start out learning about objects and how they behave. So you have to see the world as consisting of objects that behave in quite systematic and understandable ways. Then you need to have some ideas about those objects. You have to have some quick shorthand way of thinking, or before you can say, just thinking, this is a table, this is a chair, this is a cup, that's a mama, or that's a person, or this is a dog, or that's a cat.
Socks? Let's put your socks on. Yeah, sit down. The socks.
So that's a kind of conceptual level or symbolic level that's got to be in place by the time language begins to be learned.
You like how that feels?
Beginning with cooing, babbling, and then single words, language progresses rapidly through early childhood. At first, one word may express different meanings, or an entire sentence. Vocabulary flowers, and soon the child is using 2-word sentences, pairing nouns and verbs. Eventually, the child learns the rules of conversation, communicating ever more complex ideas.
Get the chalk sound. Get the chalk sound.
As the child becomes a more able partner in communication, we see the emergence of conversation recognizable to most adults.
Oh, yeah.
And we watch in wonder the unfolding of the child's mind, the development of concepts, a syntax, a grammar.
Now tell them the part that I told you to.
What does it mean to have a grammar, to know a grammar? It means that whether you want to or not, what you say and what you hear as a sentence of your language is a product of your grammar. You don't have a choice about it. As you sit listening to me talk, if you are a fluent speaker of English and you have a grammar of English, you can't help but understand those sentences that I've produced that have been coherent in any event. You cannot help but hear a sentence of your language as a sentence of your language. And it just, you extract the meaning automatically from it. You're just totally unaware of the grammar part of it. You just hear the words and you see right through it and you extract the meaning. And it's an unconscious process and it's automatic. You can't help it.
This acquisition, however, does not progress unaided. Language, like so much else, begins at home.
Mommy.
What's in there?
Brown sugar, and 2 butter.
One for me, one for you, one for me, one for Amy.
I study children in the home where they really learn how to talk. They don't learn how to talk in the laboratory at the university. So we want to look at them in the natural surrounding. What I'm really interested in is the kind of information that caregivers, and that can be mothers, fathers, brothers and sisters, uncles and aunts, anybody who is really with the children, the kind of information that they give children to convey information about the culture to them so that they learn about the world. And that includes language.
That's a zebra.
Zebra.
Yeah.
In particular, when we talk, when we're acting, when we're doing things in daily life, we're always really talking about what we're doing. And when we do that, we mark the relationship between words and the world.
7, 8, 9, 6, 7, 8, 9, 7.
Yeah, just counting them.
Perhaps one important influence in language learning is the very way we speak to children. In almost all cultures, adults tend to speak to children in a stylized speech known as motherese.
Well, motherese, first of all, is a really broad term, and it covers quite a few aspects of the kind of input that adults and even children give to young infants. So first of all, it has to do with the quality of the speech. So when we're talking to babies, usually we use a very exaggerated pitch, and we make kind of stretch sounds so that you may pick up a dolly and you'd say, hey, look at the dolly. It's a little unnatural because you're not a baby, but if to a baby, it comes very naturally. When a child says something that's really unintelligible, usually what caregivers do is expand or change the speech in a way that makes it more appropriate. What my research has shown that this kind of input facilitates children learning how to talk.
While children are learning language through others, they are also teaching themselves by doing what is known as crib talk.
Crib talk is something that a lot of children do, and parents are sort of aware of it, but it hasn't been studied very much by researchers. What we mean by crib talk is talk that the child engages in when the child's alone, either before going to sleep at night or at nap time, or often when waking up in the morning.
We can see that children rapidly learn the complexities of communication. They build new language skills on earlier ones. They learn from others and through their own efforts. Less clear and under intense debate is the biological basis for the gift of language.
2 copies.
Speaking involves the precise coordination of tongue, lips, and larynx, or voice box. Yet the biology of language encompasses far more than a mechanism for saying words. It requires the human brain, and therein lies the controversy.
You'd think that the study of how children learn to talk would be a friendly kind of field where people get along. After all, the facts are the facts, right? The baby talks, he doesn't. It's actually a field absolutely fraught with controversy. It's got some of the nastiest battles in all of the social sciences. The controversies are supposed to rage around the extent to which language is innate. But in fact, it turns out that the real controversy is a little bit different from that. Everybody agrees that human beings are biologically special in the sense that we really are the only species that acquires and uses a full and fluent language. The debate is, what's the nature of that innate preparation for language?
We have reason to believe that the brain at birth is already built so that a certain area of the brain is predisposed or prepotent for language, predisposed to be especially sensitive to linguistic information or the relevant kinds of perceptual signals so that it can be stimulated and respond appropriately. There's a structural difference between the part of the brain that seems to be associated with language in the left hemisphere and that very same part of the right hemisphere. And since we can find those very same differences before birth, we have evidence that the brain, that language is hardwired into the brain in the sense that the left hemisphere at birth already is predisposed to be the language hemisphere.
What it really boils down to is those who believe that we have evolved a special, separate brain mechanism for language, a language box, if you will, a new organ. Just like getting a new heart or a liver or some other kind of organ, the idea is we have a mental organ. Noam Chomsky, the famous linguist, actually uses the term mental organ, that we evolved suddenly at some point, a kind of an evolutionary big bang, and along came this capacity for language. The other side, the other perspective, which you can tell by how I'm setting it up, is what I believe, is that language is a new machine that nature built out of old parts. But we do it by tuning up old cognitive systems to be a little sharper here, a little longer there, a little bigger someplace else, and put together these abilities that were in the phylogenetic workshop and made a new kind of ability, but that the ability itself is not specific and special to language.
An understanding of how the brain organizes and handles language comes in part from comparing brain signals in deaf and normal hearing people.
In a normal hearing adult, input from the ears is relayed by systems in the depth of the brain to these cortical areas above the ears, the temporal lobes. Visual information, on the other hand, goes through the retina of the eye to brainstem systems and then up to these posterior cortical brain regions. So visual information is processed initially back here. Auditory information is processed initially up here. One might ask, what happens to these cortical regions in a person who's born deaf? They've never received any auditory input from the ears. What happens to these cortical brain regions? Do they just atrophy, for example, from disuse, or is it possible that they can become reorganized to process, say, visual information? And what we've observed using our neurophysiological techniques is that these cortical areas are taken over for visual processing in people who are born deaf.
While the brain can be adaptive, evidence of reserved wiring for language also comes from the study of the deaf.
What we've observed is that there is a very remarkable degree of overlap, that is similarity, in the brain systems that mediate or process sign language and spoken language. So even though language in one case comes in through the eyes, in the other case through the ears, these anterior regions of the left hemisphere, brain systems within these regions have processed both languages. So this suggests that there are actually very strong biological constraints on the brain systems that can mediate or process a formal grammatical language.
Interestingly, Sign and spoken language can build on each other when they are learned together.
Lauren and Devin both learned sign language first because my mother, who's deaf, was here with them every day. And babies have manual dexterity much before they can articulate words. So, and because sign language is a conceptual language, they could learn things like more, eat, or more milk. And they could sign those at about 8 months, 9 months old, way before they could articulate, which would maybe be 12 or 13 or 14 months old. Deaf children of deaf parents develop language skills much, much sooner because they have the manual dexterity, they have the language in their home environment, and so months before speaking children of speaking parents are articulating, they've got the concepts and the ideas, and so they have a very rich development of language much sooner.
While such effects can be observed, much more difficult is mapping the actual development of language in the brain.
It's tricky to get good electrophysiological recordings from young children because they're always moving around, moving their eyes and their muscles.
Oh, girl, look at that, right? Woo, look at those things.
We've worked very hard over the past 5 years to develop the methods to enable us to do this. And using these techniques, we've sort of studied the changes in brain organization that occur as children go through different levels of skill in the language acquisition process.
Donald Duck. Oh, there he is. There's Donald. Yeah, there's a doggy.
Duck. Toothbrush. Banana. Cereal. Shoe. Cup.
In a series of experiments, researchers plot the brain waves recorded from different regions of the brain. They then compare the brain activity that occurs in response to a word whose meaning is known with the brain activity elicited by a word whose meaning is not known.
What we typically see is that the series of negative and positive fluctuations is remarkably different for the two types of words.
When the word is known, increased electrical activity in the left hemisphere is indicated by a glowing blue-purple. When the word is not known, no special electrical activity can be seen in the left hemisphere.
Different brain systems mediate language. The systems that mediate language are not the same brain systems that are important in memory processing, for example. They're different. So this provides us with sort of biological evidence for a distinction between language processing and other aspects of cognitive processing. What basic researchers need to focus on now with the advent of these non-invasive methods of imaging the brain is on specifying those time periods in the development of the human brain when certain kinds of experience are necessary in order for those systems to develop normally.
Daddy? Daddy?
Some researchers believe it is no accident that language and certain cognitive skills develop around the same time, perhaps suggesting language is just one part of a globally developing cognitive system.
Oh, don't be frustrated. Here, look, grab this in and pull. Up we go. Pull we go. There you go. You got it. Pants.
What are the fellow travelers of language? Does language develop on its own special schedule, or is each piece of language coming in when related non-linguistic abilities are coming in? Different kinds of memory, different kinds of perceptual abilities, things of this sort. And that would be the approach that we take to asking whether language is a new machine made out of old parts or a completely new machine that was just sort of mutated overnight.
Show me how you brush your hair.
One telling ability, strongly associated with language, is the use of gesture to communicate.
As children begin to directly, intentionally share the world with you through objects. So they start by showing you things that they have. An 8-month-old might show you something that's already in his hand. 9, 10-month-old might give you the object that's in his hand. And by 10, 11 months, with many children, they begin to point to objects that they aren't even touching. And this, of course, sets up this critical triangle of communication, you, me, and it. At that triangle of reference and communication, which is indexed so importantly by pointing, is a crucial part of language because it sets the stage for learning to produce those symbols.
An important part of language and cognitive development is the ability to reproduce symbols.
Here you go. Yay! Good job. You did it.
There's a kind of a mirror image strategy, which is what we use with late talkers and other kinds of populations who aren't acquiring language normally. And that is when language fails to come in, or specific aspects of language fail to come in at the normal time, is that the only thing that's missing, or do we find telltale signs of other specific abilities that are also missing or late?
By studying normal and late talkers and their ability to use gestures, researchers have gained new insights into language development.
I identified a group of children who were delayed in the early production of words. So they were the children who were in the lowest 10th percentile for using words, for actually saying words, using words in a communicative way.
In this research, the late talkers were compared to a group of younger children who were at the same verbal level, as well as to a group of children their own age, but with normal language skills.
Thank you. Here's another one.
One of the measures compared the child's ability to use gestures or language symbols and the child's vocabulary level.
Okay, your turn. You do that.
This allows us to examine the child's ability to produce recognitory gestures, at least within this structured paradigm. We have called this our gesture lexicon because it represents the ability to produce the symbol, the recognitory gesture, similar in a way that's similar to their ability to produce or reproduce a word.
Something else.
This experiment indicated that a child's ability to use single gestures is closely linked to the ability to produce words in both late talkers and children with normal language skills. Surprisingly, this linkage did not hold true when researchers compared how children learn to sequence symbols.
Watch what I do because he's hungry. I'm going to put him in his chair. Then I'm going to put on his bib. Yeah, then I'm going to feed him some apple. And then I'm going to wipe off his mouth. Okay, he's still hungry. You take care of Teddy. He's still hungry.
The difference between this and the other task, the single gesture task, is not only that we have 4 specific events that have to be modeled here, but also that they occur with a supportive context. You've got all the props for carrying out the task right there. But we also can look at how many of those symbols a child puts together into a connected whole sequence. So we can get an upper limit. How many of these symbols will the child chain together without stopping? And we also can then measure how many of those are put together in the proper order, the way they were modeled.
Mm-hmm.
Is this ability to sequence gestures and events related to the child's developing ability to form sentences?
We're not implying that this is really syntax, but we're just trying to draw the analogy between the ordering principles used in syntax and the ordering that's required to remember the order of these gestural sequences, and suggesting that perhaps there is some ability to solve that kind of ordering problem that's developing at that point in time that we can measure.
What should I do for him? He's sleepy. I'm going to put him in his bed. Then I'm going to cover him with a blanket. Then I'm going to read him a story. Read him a story. Then I'm going to kiss him goodnight. Night-night, Teddy. Here you go. It's your turn. Teddy's sleepy, Mickey. Can't you take care of Teddy?
In the sequencing task,
The late talkers were like children who were their same age, but who had better language production skills. They were not like children who were at the same language level. This suggests that the ability to sequence whatever symbols the children already have and can use is not connected with the level of language production.
By studying gesture and sequencing in late and normal talkers, researchers found that the underlying abilities necessary for language were already at work in other mental arenas.
There's a correlation here between gesture sequencing and the children's level of comprehension, which corresponds very nicely to what we see in normal children.
Our ability to produce and learn a language is unique. There's nothing else like it in the universe that we know of, at least on this planet. But that doesn't mean that we do it with a language box. That doesn't mean that we developed a special piece of brain just for language. It's a wonderful, wonderful ability, but it may be a wonderful ability that we achieve with a general purpose, pretty good brain.
So is language a loosely connected neural system, drawing heavily upon other mental abilities? Or is it a particular brain mechanism, waiting for experience to set it into motion? By exploring the connections between language and thinking, we can better understand how most children learn language along a predictable timeline, and why some do not. Whatever the answers, the child, eager to communicate, quickly learns this most complicated and beautiful dance of the mind.
I don't have enough room to travel. Oh, poor baby. Yeah. In a big living room. Hey! What can you do?